Hello, I'm Himanshi Nigam from IIPS DAVV University, Indore, and here I'm explaining consequences of floating point representation. Let us first begin with the first consequence of floating point representation, which says non-associativity of arithmetic. Here, the numbers which has to be truncated to fit into the 4 mantissa digits allowed in our hypothetical computer for each number, this truncation leads to a number of seemingly surprising results. For instance, 2 by 3 into 6 is equals to 4, as we all know. Now, when the arithmetic is performed with the floating point numbers 0.6667, which comes by dividing 2 and 3, added 6 times, it gives 0.3998 E1, where E is the exponential in the powers of 10, whereas 0.6667 multiplied by 6 gives 0.4000 E1. In other words, it concludes that equation 6x is equals to x plus x plus x plus x plus x plus x is not true. Moving on, we can see the next consequence of floating point representation, in which the associative and distributive laws of arithmetics are also not always valid. Let's begin with associative law, which says that a plus b minus c is equals to a minus b, a minus c plus b. Here we can take some values of a, b and c like this. A equals to 0.5665 E1, where b is equals to 0.5556 E minus 1 and c equals to 0.5644 E1. Here, when we calculate the value of a plus b, we get 0.5720 E1, and then after we calculate, we subtract c from this value, we get 0.7600 E minus 1. This is our left hand side of this equation. Now we calculate a minus c, which comes to be 0.2100 E minus 1, and then we add b into this, we get 0.7656 E minus 1. This is the right hand side. We can see from these two values that the left hand side is not equals to right hand side, that is, the equation of associative law is not satisfied in case we use the floating point numbers. Now let us see the distributive law, which states that a into b minus c is equals to ab minus ac. Here a is equals to 0.5555 E1 and b equals to 0.4545 E1. Here we take c is equals to 0.45. Here we take c equals to 0.4535 E1, and then we calculate the value of b minus c, which comes to be 0.1000 E minus 1, and then we multiply a to it, which will result in 0.5550 E minus 1. This is our left hand side of the equation. Now we calculate a into b, which comes to be 0.2524 E2, and AC comes to be 0.2519 E2. Here then, if we subtract AC from AB, we get 0.5000 E minus 1. Here we can see that here also the left hand side is not equals to right hand side, and there are some loss of significant digits in the right hand side part of the equation. So we can conclude that the distributive law is also not satisfied here. Now second, the consequence of floating point representation is the concept of zero in floating point. Like the number 0, as we all know, has a precise meaning in arithmetics. While doing arithmetic with real numbers represented in normalized floating point mode, exact equality of a number to 0 can never be ensured. Like for example, if we equate 0.0004 with 0, the answer would be incorrect because there will be a loss of significant digit, which is 4. That's all. Thank you.